Today on How It's Made. Pocket knives. Soapstone products. Electric pole transformers. And traditional snowshoes. Pocket knives can be used to cut rope or slice an orange. Just unfold the blade and you're good to go. Folding knives actually date back to ancient Rome. Many centuries later, the smaller pocket-sized versions came along, so people could carry their knives without shredding their pockets. Pocket knives can pack a lot of punch. They often contain several blades and tools, all of which can be retracted into the handle. To make pocket knives, rollers first feed a strip of stainless steel to a series of dies. Then dies punch out blade shapes. They cut holes in the handle for installation, stamp on the company logo, and create grooves so the user can get a grip. A trip into a fiery furnace hardens the metal. It's the first step in heat treating the blades. Once they're cool, the blade shapes are placed on the magnetized rim of a rotating carousel. It moves the base of the blades under an induction heating coil. The heat anneals that end, making it pliable enough to bend and easier to fit in the pocket knife handle. A robot now transfers a blade shape into a computerized grinder that bevels the edge but leaves it blunt. It won't get its cutting edge until later. Here, you can see the difference the grinding makes. Vibrating ceramic pellets polish the blades with paste for 32 hours to achieve a mirror finish. A magnetic belt collects them and transfers them to the next station. Meanwhile, a rocking cutting tool carves ridges into a piece of cow shin bone, which will adorn the pocket knife handle. A bag of those ridged shin bones are dipped in dye, tinting them a vibrant green. Cow shin bone is just one of the many materials used to adorn the knives. Some are synthetic and some are natural. Like this material, mammoth ivory. Using epoxy adhesive, workers decorate these pieces of bone with embellished metal inlay. Then, they trim the excess bone so that it's flush to the metal liner. Next, they place a spring on the underside of the bone and brass part, followed by a rocker arm and a spacer. This sandwich is finished off with another bone-covered brass liner. Workers insert blades in one end, first dipping them in oil for lubrication. A pin holds it all together. A separate set of blades goes in the other end of the pocket knife, and another pin is inserted. A pneumatic tool flattens the ends of the pins, riveting all the parts together. Sometimes, a shim is pounded between the layers so the knives can move more freely. It's a little fine-tuning. The pin heads are grinded down to blend them to the rest of the pocket knife. Sparks fly as workers hone the beveled edges against a belt sander until they're sharp enough to cut. Next, all the blades are retracted and the knife is buffed until it shines. Here, a laser etches an insignia into the bone handle. The engraving is enhanced with paint, and now you have a pocket knife that's sharp and sharp-looking. Coming up, Soapstone products, a real rock and roll story. Dig deep into the history of civilization and you'll find plenty of soapstone. Over the centuries, it's been used to make everything from cookware to countertops to the kitchen sink. Soapstone doesn't stain or burn, and that's why it continues to be a rock-solid material. But before you can make something out of soapstone, you need raw materials. Several deep holes are bored into a soapstone hillside. The horizontal and vertical holes form an intersecting lattice. Miners loop one end of a long diamond-encrusted cable and attach it to a rod. This makes it easy to maneuver as they snake the cable through one of the vertical holes. A coiled snare is attached to the cable's other end and inserted in one of the horizontal holes, jiggling it around it until the snare snags the loop. Next, the cable is threaded through the rock. Two ends of the cable are crimped together to create one big circle over 200 feet in circumference. A section of the diamond cable is wound around mechanical wheels. The machine moves backward as the wheels turn the cable through the rock, and slowly but surely, the tiny diamonds saw through the soapstone. The process kicks up a lot of talc, the mineral that gives this stone its soapy texture. So water is sprayed into the cut to minimize the dusty fallout. As the cable exits the rock, it snaps off the wheels, so everyone has to steer clear. It has taken about 20 minutes to slice through this soapstone hillside. Now, it's time for the excavator. As it pulls the soapstone away from the hillside, the slab breaks into chunks, each one about 2 or 3 square yards. The chunks are washed. Then, they're lifted up by a front-end loader and delivered to a bandsaw. Like the cable, the saw has a diamond edge that easily cuts through the stone. They get several 1-inch thick slabs from each block, perfect for a countertop. The smaller end slabs are used to build apron sinks. This type of sink was first popular a century and a half ago. But these days, computerized blades and lasers make the job of building one a whole lot easier. The laser lines serve as guides, while the blade cuts the soapstone to precise dimensions. This piece will be the bottom of the sink. A precision grinder tapers the sink bottom from the center out so that liquid will flow down into a drain in the middle. Next, a drain hole is punched out. A constant flow of water keeps the cutter cool and the dust down. Epoxy resin is mixed with hardener for a high-strength waterproof adhesive. It's quickly applied along the edge of the sink bottom so it doesn't dry. Then, a sink wall is pressed onto the glued surface. They piece together the rest of the sink, and it's ready to blend in with a soapstone countertop. From the shower floor to the stove surround, Soapstone can perform many functions with style. When we return, the shocking truth behind electric pole transformers. Electric transformers. We see them everywhere, but often take for granted the big part they play in our everyday lives. Their job is to transform the high voltage from electrical power lines to the lower voltage that's suitable for home use. Without them, raw electrical power would be virtually useless to the average person. Transformers are a critical part of modern life. But did you ever stop to wonder what's inside those canisters? To build a transformer, workers start by taking paper that's coated with epoxy glue and tape it to a wooden block. Next component, an 1/8 of an inch thick aluminum strip. It's a metal that can withstand the heat that a high voltage current produces. As the block is rotated, the paper and the aluminum strip are wrapped around it. An aluminum bus bar, called the low voltage lead, sends low voltage current out from the transformer. Workers fold the lead and move the unit to another rotating block for more wrapping. The insulating paper has epoxy glue on both sides. This glue will later melt and bond several components in place. On the next block, a worker tapes on more epoxy paper along with epoxy-coated copper wire. He covers the paper. Then repeats the same process, forming a second layer of copper wire. He solders a high voltage lead wire to the copper wire, then rolls yet another layer of copper wire. Next, he welds on what's called the lead wire out, the wire that'll protrude from the transformer's cylinder, and attaches vinyl-coated wires that'll connect to different voltages out of the transformer. This completed unit is called the coil. Now, using electrical steel, workers build the transformer's other main component, called the core. The coil and core are tightly secured together with metal strapping, which will help to fix the assembly in the tank. Then it's into an oven, where they bake for 8 hours at 275 degrees. The heat improves insulation by removing any traces of humidity. It also melts the epoxy glue, fusing together the paper, the aluminum strip, and the copper wires. The assembly now goes into a steel tank. A rubber gasket is hammered around the perimeter, and a grounding wire is bolted on. Then 3 thermoplastic bushings are inserted. Workers connect the low-voltage lead to the thermoplastic bushings, then bolt the bushings to the tank. They adhere an oil filling guide to the side of the tank, then position an automated filling machine. A machine fills the tank with mineral oil, drawing a vacuum to make sure the oil disperses throughout the coil and core. The oil is used for its thermal and insulating properties. An internal fault detector will alert maintenance crews if there's a short circuit. A worker runs lead wire through the thermoplastic bushing and secures it in place. Next, comes the high voltage connector. Finally, the tank cover is bolted shut. The transformation, so to speak, is finished. Before transformers go into service, they have to undergo some truly electrifying tests. This equipment simulates a 145,000-volt lightning strike. Then it's into a water tank to test the transformer for leaks. If it passes muster, it could soon be appearing on a pole near you. Up next, how they make snowshoes, step by step. Historians believe the ancestors of North American native peoples brought snowshoes with them when they migrated from Central Asia some 4,000 years ago. Today, the tradition of snowshoe making lives on, thanks to skilled artisans who combine an age-old craft with a few modern improvements. Every snowshoe frame comes from a single piece of hard wood, usually white ash. Craftsmen start with a 2-yard strip about 3/4 of an inch thick. Using a planer, they thin the middle down to about 1/2 an inch. Then, it's onto a table saw, where each end is tapered to a fine point. They take the trim pieces known as bows and hammer steel braces onto each one. These support the wood where it's thinnest so it won't break later on during the bending process. The bows go into a steam chamber to soften the wood. "30 minutes later, they're damp enough to bend without breaking. The craftsmen start working from the middle, the area called the faux, where the wood is thinnest and easiest to bend. They wrap it around a steel form on a bending jig. Then lay one tapered end over the other and tack them together. Now, back to the steamer for a second bow to complete the pair. A temporary crossbar helps hold the shape. Different steel forms are used to shape different snowshoe models. The frame is set on a bending machine called a press brake. Then a wooden bar is positioned on the frame to act as a fulcrum. As the press comes down, it curves the tip of the frame about 2 3/4 inches upward. A crossbar is inserted lengthwise to hold the bend in place. Still damp from the steam chamber, the frames will need to dry out for several days. Only then can the temporary crossbars safely come out. The craftsmen then sand the wood to a smooth finish. They drill slots on the inside for the 2 permanent crossbars, while another machine stamps those bars with the company logo. It takes just a quick stretch to insert the bars, one near the toe, the other near the heel. Now, the frames go for a dip in a vat of oil-based varnish to seal and waterproof the wood. Once the varnish dries, the frames are ready for lacing. In keeping with tradition, the laces are made of animal hide. Wetting it makes it easier to cut into the long strips. A skilled weaver threads her needle, then begins by hooking the rawhide lace through a nylon thread that runs along the shoe's inside perimeter. She nimbly builds up a pattern of webbing that always begins and ends with a series of triangular shapes. This intricate weaving technique is a traditional skill passed down through generations of Native Canadian women. She finishes by wrapping up the heel end of the frame with rawhide, then pulls it tight. Now that the toe piece is finished, she starts weaving the middle piece. Using a large width of rawhide, she builds up another web of triangles, this time knotting the strips directly onto the frame. Finally, she weaves an opening to leave room for the bindings that hold the snowshoe to your boot. Once the rawhide dries, the webbing will lie taut across the frame. The last step? Another coat of varnish to seal and protect both the wood and webbing. And now, these traditional snowshoes are ready to make some tracks. If you have any comments about the show, or if you'd like to suggest topics for future shows, drop us a line at sciencechannel.com/howitsmade.